Assalamu alaikum. Can you all hear me? Can you hear me? Okay. Alright. Yeah. I hope all do. Right, anyway, let's get started. Just to recap on last week's lecture, we did talk about different numbering systems. We talked about the decimal numbering system, talked about the binary, the hexadecimal, and the octal numbering systems. And we also talked about the conversion between the different systems, and I hope you all followed me on last lecture, because it was an important lecture to get you started in the numbering business. Right, okay. So today we have a new topic, and the title of it, it's using a new start using this new pen technology. It's quite interesting, better than using a mouse. So you just have to bear with me, because I'm trying to get trying to get used to the handwriting of it. Right, okay. So the title of today's lecture is, I start making mistakes. Right, okay. Start again. The title is binary operations. Now, please do excuse my handwriting because of the trying to get used to it. Anyway, right. So binary operations. So today we'll try to have a look at how we deal with the binary. How do we add binary? How do we subtract binary? And how do we multiply binary? And also we're going to have a look at the if we have a negative number, يعني أرقام بالسالبة في الباينري. By the way, today's slides are available on Blackboard. I did put them on Blackboard, but I found the slides are rather confusing, or probably they don't give much details. So I'm going to give you my own. I prepared my own slides, my own lecture, sorry. So I will give you my own lecture. So today will be based on all just writing. So just keep, stay focused with me. Right. So binary operations. Let's have a look first at binary addition. So I will have we'll start by having a look at how do we addition. How do we add binary together? How do we add numbers together? So if we have, for example, this number 1 0 0 0 1 0 1 1. Now this number in binary equals to 209 in decimal. Now you should all know how did this come from. Okay, you should all know how did this come from last lecture. If you still not sure how do you do the conversion, then you've got to have a look again at yesterday's lecture. You've got to learn this technique, and if you do have problems, you can always email me as we agree. Now, if you want to add this number to the following, we have 1 1 0 0 1 0 1 0. Okay, so I'm dealing with 8-bit number. If you can see 1 2 3 4 5 6 7 8. So this is an 8-bit number. If you notice the second number, I added a 0 here. Just as I said, always the 0 to the left of the number. They do not make any difference to the number. But it is good to put them in most cases. In most cases, it is good to put them just to keep our work tidy. So we've got the same number of bits that we are dealing with, just to get ourselves organized. Now, so let's add these numbers and see how things are added. Now, if we add 1 to 1 in binary, it's not 2 obviously, because we're dealing with binary, so you've only got to put zeros and ones. So it'll work this way. So 1 plus 1 in binary is 0, and we carry 1. يعني باليد واحد إذا تذكروا من أيام الرياضيات في المدارس. We carry 1. This is called carry. This is called the carry. Okay. So now we add this carry the next column. 1 plus 1 is also 0, and the carry is 1. 1 plus 0 plus 0 is 1. 0 plus 0 is 0. Again, 1 plus 1 is 0 and the carry is 1. 1 plus 0 is 1. Again, 1 plus 1 is 0 and the carry 1. 1 plus 1 is 0. Obviously, on the carry 1, you've got no numbers here, so we're going to have to put it down here. Now, this number, the second number, if you work it out, it does equal to 83 in decimal. Now, this number, which we got in binary, it equals to 292 in decimal. Now, to check whether we've done this correctly, to check, you can add these numbers, right, and have a look at the result, and then you know whether we've done our work correctly or not. Okay, so that's the first operation, is the binary addition. Very easy. I've only given you one example because all other examples will be exactly the same idea. So let's open a new page and have a look at binary subtraction. عملية الطرح. binary subtraction. Binary subtraction. Right, okay. With the binary subtraction, let's have this number 1 0 1 1 0. We'll have 1 0 1 1 0 0 1. Right, 1 2 3 4 5 6 7. I'm dealing with 7-bit number here. Let's have which this number equals to 77 in decimal. Okay, let's subtract this number from it. We'll have 1 1 1 0 1, and I'll add a couple of zeros here again just to get our work organized. Now, let's do the subtraction. Subtraction is quite different to do it in here. So, right, this number, by the way, the second number, equals to 23 in decimal. Right, okay, so let's start doing the subtraction. 1 minus 1 is, of course, 0. Now, this is the second column is quite tricky one. Now, 0 minus 1, obviously we cannot do that, so I'm going to have to borrow. Do you remember back in the school, we used to do the borrowing if we had like a number smaller than the other. So we have to borrow from this one. So this one will become 0. Now, this 0 here will not become 1. It will become 2. This is the way it goes in binary subtraction. So 2 minus 1 is 1. Now the same thing again, 0 minus 1 we can't, so I'm going to have to borrow from this. So this will become 2. 2 minus 1 is 1. Okay, 0 minus 0, no problem, is 0. Now this one here, again, 0 minus 1 doesn't work. We're going to have to borrow from this one, but this one also 0, so we cannot, so I'm going to have to borrow from the third one, from this one. So this one will become 0, this one will become 2, but don't forget, we're going to lend 1 to this one here. So this one will become 1, and this will become 2, right? So 2 minus 1 is 1, 1 minus 0 is 1, and obviously we've got 0 here. It's up to you, can put it or not. I'd put it just to keep ourselves again. As I said, we started with 7 bits, so let's finish with 7 bits. 1, 2, 3, 4, 5, 6, 7. Okay, so always keep your work consistent, right? So this number in binary, it does equal to 54 in decimal. Now, if you subtract these numbers, you should get the same 54 number. Again, you've got to be able to do the conversion as we had in the last lecture. It is very important, otherwise you will have problems later. So any step I give you, you should be very confident with it. Okay, so when I give you any step, you should go, well, after the lecture, you've got a week to study it. Make sure the next lecture you come in, you know what we've talked about. So you know what we've done. So the work does not accumulate on you, otherwise you'll have problems. Right? Okay, so this is the second operation. Let's have a look at the third operation. Let's do binary multiplication. multiplication. Again, excuse my handwriting. Obviously, it's very different from writing, on normal pen and paper. Never mind. I'll get used to them eventually. Right. So if we have these numbers, let's have this number 1, 1, 1, 0, 1, and I'll have the next number to be 0, 1, 0, 1. I'll keep it this way. I'm not gonna add 0 here. I'm not gonna add a 0 here. You'll know why I'm not gonna add a 0 here, because I don't want to complicate things. This is a multiplication. It gets a little bit like messy if we have an extra 0 here. Well, okay. So this number is equivalent to 23 in decimal, and this number is equivalent to 10 in also in decimal, right? Now let's do the multiplication. Now remember back in the schools when we used to, for example, multiply these numbers, for example, 23 times 10. You're gonna have to multiply first the zeros by these numbers. Is that right? And then you have to, and then what you do, you shift one place, so izaha, and the next line, and then you multiply the 1 by 23. So and then you add them up. You will have, and then you add them up. Is that right? And then you'll have 230. Okay, so it's the same idea applies to the binary. So let's start again. So 0 plus all the above number, obviously it will be zeros. So we're gonna have 5 zeros in here. 5. Now we're gonna start with this number. So we did this number. 0 plus 0 times anything will be 0. Now this number 1. Don't forget, we're gonna have to shift one position. So I'm gonna have to put a 0 in here. Now 1 times anything will be exactly the same. So I'm gonna have 1, 1, 1, 0, 1. Now we're gonna start with this number here, the 0. Obviously, don't forget, this time we're gonna have to shift 2 places. Okay, you have to shift 2 places because this is the third number. 0 times anything will be just 0, so we're going to have 5 zeros in here. Okay, so to the last number, I'm going to have to shift 3 places, so I put zeros in here. 1 times anything will be exactly the same number again, so 1, 1, 1, 0, 1. Sorry, I had this is in a funny order, but never mind. So let's add them all up. Zeros. Okay, 0. We've got in this column, we've got, don't get confused, this column will get 1. Also, this column will get 1. Now, in this column, 1 plus 1, don't forget from the addition, is 0, we carry 1. Now, again, 1 plus 1 is again 0, we carry 1. Now it's quite different. Now, we have 3 1s. I told you when we add 2 1s, we'll have a 0 and a carry 1. If we add 3 1s, we'll have a 1 and the carry is 1. So we'll have a carry 1. So we'll have 1, 1. Right, okay. So this number is in binary. Oops. This number, no, okay. Sorry about the mess. This number is in binary. It should equal to 230 in decimal. This is how we know that our work is correct. Okay, so I hope you all understood this. Right. Let's move on now. What if we have a negative number? Let's start dealing with negative numbers. يعني بالأرقام السالبة. Up to this point, do you all understand? Up to this point, do you all understand? Okay. I hope you do. Maybe one student not quite sure, or 2 students, right? So I hope the majority. I mean, come on, guys. When I ask question, do answer. You are 62 students. So do you understand? It's either yes or no. There's no in between. So you either do understand or you do not understand. Okay. So far, the majority understand. Only few do not understand. So for those who do not understand, it's okay. Just go back to the lecture again, the recorded lecture. It is recording, and just have a look what I've been doing. Also, you can email me later as well if you get stuck in these. Okay. So let's move on. So now, again, what if we have a negative number, negative binary number, يعني عدد سالب. Okay, so let's have a look how we deal with negative numbers. Okay, how do we deal with الأعداد السالبة? Now remember, as I told you in the first lecture, computers do not understand letters nor symbols nor numbers. They only understand zeros and ones. So when we have a plus and minus sign, عدد موجب وعدد سالب, they have to be represented in zeros and ones. So always the computer represent the plus as 0 and represent the minus as 1. So always the minus in the computer, the minus sign is 1 and the plus sign is 0. Now we have three methods, okay? We have three methods to represent a negative number. اوكي في عندنا ثلاث طرق من خلالها نقدر نعبر بالكمبيوتر عن النيجاتيف نمبر العدد السالب. The first one is called the sign magnitude. The sign magnitude. The next one is, or the second method is called ones complement. This is a 1 فارزة S ones complement. Okay, and the third method is called the second, twos complement. Okay, so we have three methods to represent negative numbers in binary. We have the sign magnitude, we have the ones complement, and we have the twos complement. For example, I'll just have one here. If we have the number 5 plus 5, it is represented. Now, I'm going to open the chat. Can you tell me what is 5 in binary? You should all know this by now. What is 5 in binary? What is 5 in binary? Come on, guys. You should know that. Yes, thank you. 101. Okay. You answered me a little bit with reluctance, right? Okay, you've got to know, as I said to you, you've got to know these conversions. Not 0. Why 0? It's not a 0. Converting 5 into a binary, it's not a 0. Come on, guys. We had this last week. You've got to be able to do the conversions. We had that last week. So now this should be like a very easy task to you, right? Okay. So yeah, it is let me turn the chat off again. It is 101. Right? So the 5, as we all know, we should know anyway, is 101. Now to know that this is a plus number, so we're gonna have to put a 0. So we put the sign to the very left of the binary number, just like we do in the normal numbers. In the normal numbers, where do we normally put the sign? We put it to the left of the number. Exactly the same in binary. We put the sign to the left of the number. Now, how can I distinguish between a 5 and a normal binary number? Now, we do tell you. I'll give you an example now. So if we have minus 5, so we have the 5, how do you represent it? Minus 5 will be represented like this, okay, with the 1 which equals to the minus sign. We have it here. Now, how do we know that this is a minus 5 and not 13? Because in normal binary, this is 13. 8 plus 13, this is 13. Now, how do I know that this is a minus 5 number, not a 13? We do tell you in the exam what to do. So in the exam, if I tell you we have a negative number or anything like that, I will make it clear to you. in the exam, I will make it clear to you that we have a sign number here. Okay, so in the exam I will not trick you. The questions will be clear to you, so you will know that this is not 13. This is a -5 number. Okay, all right. So let's move on. Let's have a look at the first method. I'll say to you, we'll take each method separately and we'll discuss them. So the first method, as I said, is the signed magnitude. The signed magnitude, right? Okay. In the signed magnitude, the value will not change because it's the magnitude. Magnitude means qima. Qima is a qima. Magnitude is magnitude. So it will not change. What I mean by this, so you know, for example, okay, +3 will equal to obviously we know 3 is 110. Okay, we'll add another one. We'll add another 0 to show that this is a +3. Now, on the other hand, -3 is also 110. If you want to work in 3 bits, but we add a 1 to the left-hand side of the number to show that this is a -3. Now, the problem with this technique, we'll call the disadvantage. Disadvantage. You know what this disadvantage means? يعني المساوئ أو السيئة تاع المethod هذه. The disadvantage of this method can't include the sign bit, can't include the sign bit in addition. I'll explain to you what I mean now. Okay, we cannot add the sign magnitude in addition. For example, now if we look at these two numbers, the 3 and +3, if we want to add them together, we said the +3 is 1100. The -3 is 1101. If I want to add these numbers together, right, I will have 0 + 0 = 0, and we have 1. 1 + 1 + 1 is 1. We carry 1, and then we've got 1, and then we've got 1. But okay, now have a look at this number, which we have a problem in here. Now, obviously, we know that the most left number is the sign, and this is the binary number. Now, this number here, what does it equal to? I'm going to open the chat, and you better answer me right. The 0 and 1, what is it in decimal? 6, thank you. Yes, that's right. 0 and 1, thank you very much, yeah. 0 and 1 is 6 in binary, which means that the number we got is -6. Now, is this correct? I've added 3 minus 3. Theoretically, well, the answer should be 0. Is that right? +3 minus 3 should equal to 0. But I got -6. So we do have a problem. Okay, so this method is good in showing you the negative, but it is not good in actually doing the addition, because in doing the addition, it cannot handle the sign thing. So eventually you'll get a wrong answer. So, which is why we use the complement. So let's have a look at the first method of the complement, or the second in representing the negative numbers, which is the ones complement. We just for the short we put a comp with the dot. That's this for short term for complement. Now let's have a look at the complement. Now the rule of the complement, of the ones complement, that all zeros become ones, and all ones become zeros. Right, okay, what do I mean by this? Right, let's have an example. For example, Okay. For example, subtract. Oops, what am I doing here? Sorry. Subtract 1. Let's. Oh no, hang on. Right, okay. Before this, I've jumped to the next example. Okay, find. Sorry, before I jump to this introduction, find the representation. Find the representation of minus 17 in decimal using one's complement. See, in the exam, see what I'm doing here? In the exam, I will make it clear to you what to do, or what method to use. I will not, I will not confuse you in the exam. I will tell you what I want you to do. So, for example, if I give you this question, I will tell you which method to use. So you should be very confident in everything here, because I will tell you what I want you to use, and you've got obviously to use it in the way that I want you to use. Okay. So let's have a look. Now to find number 17, minus 17 in binary, we've got to find 17, because we cannot just find minus 17 straight away in binary. We've got to find 17 first, and then convert it into minus. So 17. Now, if you are clever enough, I'm going to open the chat. Tell me what is 17 in binary. Try to work it out. You've got 1 minute. Work it out. No. Come on, guys. 17. Okay. Almost. No? Right, guys, whoever is putting 1 and then zeros, this is just a 1. Right? Some students have been doing 1 0 0 0 0 0. This is actually 1. This is 1. Okay? So I'm sure you've got right now you're making mistakes. Now this number is right, 1 0 0 0 1. Okay, right, guys, I'm a bit disappointed because we had this last week, and it seems that you do have some problems. So you've got to go back after this lecture and revise what we had last week, and do some extra work yourself. Go to the net and just have a look at the binary conversion and stuff like that. So you've got to be confident. So by next week, you've got to know all of these stuff, including today's lecture. Right? Okay. So the number 17 in binary is 1 0 0 0 1, but I will add 3 zeros. So this is the number. Okay, so I think one student only had this answer, which is right. And I'm just going to add some zeros. As I said, zeros to the left of the number will not affect the number. But I'd like to add, normally, if you're working with the plain numbers like this, normally it is good to work in 8 bits. Okay, in 8. Obviously, each one is a bit, so we work in 8 bits. Normally, the computer does work in 8 bits, so we normally try to work in 8 bits. Anyway, so this number is actually 17 in decimal. Now let's convert it into minus 17. Right? Now let's go back to the rule. The rule says all zeros become ones, and all ones become zeros. So the minus 17, according to the ones complement rule, will be like this: 0, 1, 1, 1, 0, 1, 1, 1. And bearing in mind, this is just brackets. This is a bracket. Bearing in mind that this is the minus sign. As I said to you, always the sign is the digit or the bit that is the very far left of the number. The very far left of the number. So this number here equals to minus 17 in decimal. Okay, right? Let's do an example here. So let's do some arithmetic calculation. Now, if I say to you, this is an example. Okay, and I ask you, the question will be something like subtract subtract the number 1, which is in decimal, from 5, which is also in decimal, using one's complement technique. Okay, so I'm asking you here what to do. I'm asking you to do this. To do this. Okay, I'm asking you to subtract 1 from 5 using the one's complement technique. Now, also, this is a standardized rule. So I'm going to give you one example or 2 examples, and you can apply them to all the one's complement problems. They're all the same. They hold the same idea. Now, always the number that we are taking it from, it's the number that we are taking it. This number you usually change it. Can you see? It's minus. So this number you change it to one's complement. Now, what is the? We all know what is 1 oops. Let's work with 4 bits. Right. We all know what is 1 in binary. It's 1 0 0 0. Now the minus 1 should be, according to the one's complement rule, should be like this. Okay, so the 5, we know what the 5 is. The 5 is 0 1. Sorry, 1 0 1. Is that right? Okay, it's 1 0 1, and because it is a plus, I'm going to add another 0 here. Okay, if we come to the minus 1, is 0 1 1 1. Now what do we do with them? We basically add them. Why do we add them? It's just like saying 5 plus minus 1 is the same thing. Is the same thing. Okay. So this is how the way we work it in binary. So we say 5 plus minus 1. So this is the 5, this is the plus, and this is the minus 1. So now we just do a normal addition. So 1 plus 0 is 1, 1, 0, 1. Okay, 0 1. Now note something. Now how many bits in here? There are 4 bits. Same in here. Now note something here. We've got 5 bits. So the 5th digit we got, this one, we call it in mathematics, we call it overflow. يعني الفائض لأنه الأصل يطلع عندي 4 bits لكن طلع عندي bit زيادة. We call the overflow the file. Now, if we get this in the one's complement, right? Okay, you've got to concentrate to what I'm saying now, because what I'm saying are actually rules. Okay, so if we get an overflow in the one's complement, what we do, we simply put it here and add it back to the result we got. So we add it. So 1 plus 1 again is 0 باليد واحد. 1 plus 1 is also 0 باليد واحد. 1 will come down and 0. Okay, so now we have this number in binary. Now note something. The most left bit in this number is 0, which means plus. So this number is equal to plus 4 in decimal. Now go back to the number. 5 minus 1, what does it equal to? It equals to plus 4, which means our work is correct. So we have no problem. Okay? Now, let us take another example. This time I'm going to ask you to do this. You do 5 in decimal minus 6 in decimal. We know the answer, obviously, in mathematics. The answer should be minus 1 in decimal. Now let's work it out in binary. Now, according to the rule I said to you now, which number? I'm going to open the chart. Which number do we need to change it to its one's complement? Which number? Okay, that's right. 6, yeah, that's right, thank you. Okay, so thank you very much. You all answered correct. Right, so number 6 is the one that we need to change back to one's complement. So number 6, we'll do on the side. Number 6 is like this, is that right? 0, 1, 1, and then we have 0 for the positive number. Now, to change it to its one's complement, obviously we do the opposite. So we get 1, 0, 0, 1. So that's in one's complement. Now let's do the addition. Same idea. So you get 1, 0, 1, 0 plus. So it's got messed up. Plus 1, 0, 0, 1. Okay, let's do the addition. 1 plus 1 is 0 بيد واحد. تنزل هذا واحد، هذا ينزل واحد، هذا ينزل واحد. Now, okay, have a look at something here. Now, we do not have an overflow here. There's no overflow. Can you see we've got 4 bits as we started? But the most left digit here is 1, which means the number is in minus. Now, if this happens, if you get 1 on the left-hand side, you need to change the number back to its origin, because this is still in one's complement. So we need to change it back. So we do the reverse thing. So we have this change. The zeros become 1 and the ones become zeros. So we have this number here. Now, this number in binary, what does it equal? Equals to 1. Okay, fine. Do not forget that you have a minus to begin with. So the minus have to come down here. So you put the minus here. This you have to remember from your head, you know, when you're doing the exam. Obviously you're gonna have to change back to this number, but do not forget that you have a minus number here. So you have a -1 that's in decimal. Same. So if you go back, this number is equals to this number, which means our work is correct. Okay, so our work is correct. Now, we have a problem also. We have a disadvantage in this method. The disadvantage is, I'm going to share my desktop with you. Okay, I'm going to share my desktop. Right, okay. Now, let me get this internet thing done. See you later. Okay, let's get this thing done. Let's get this done. Right. Okay. Can you just let me make sure? Can you all see my desktop? Can you see my desktop? Yeah. Okay. You can see my desktop. Okay. Good. Right. Okay. I've made this table here. Have a look at it. Okay. It doesn't open for some reason. It opens now. Okay. Can you see the first, the one's complement table? Now have a look at this table. Now let me use the mouse. Right. Can you see? This is the way the numbers go. 7, 6, 5, 4, 2, 1, and then -1, -2, -3. These obviously like they are the opposite. For example, if you take the 7, is 1, 1, 1, 0. But if you take the -7, is the opposite, 0, 0, 0, 1. Now we do have a major problem here. Now look at the 0. We have a 0 and we have a -0. Because obviously the 0 in binary is 0, 0, 0, 0. Now if we use the ones complement, as we said, the zeros will become ones. So you'll have 4 ones. Now this is a mathematical problem, because obviously you know, we cannot have we cannot have -0 in math. Right, okay, so let me go back so I can see you again. View whiteboard. Okay, yeah, we're back again. Now, yeah, as I said to you, we have a problem, because we cannot have a -0 in mathematics. So so there is a weak point in this methodology, which is the one's complement, which is why the most reliable method of doing representing or subtracting the a negative number is to use the 2's complement. method. So we have the last one, which is the 2's complement method. So this is the most reliable method, right? In this method, which is the 2's complement, we have two ways. We have two ways in changing the numbers to negative, but I will give you the easier method. We have two ways to it's not like the 1's complement, as I said, we make the zeros ones and the ones zeros, and then we have a 1's complement. In the 2's complement, we have two ways in doing this, but I'll give you the easier way. The easier way says, right, change. This is the rule. Change the bits after. I'll put this in capital so you can see it well. Change the bits after the first one from the right hand side. So from the right hand side, you scan the number. When you see the first one, you keep it, and then the numbers after that you change. For example, if I give you this number 0 0 1 0 1 0 0 0, and I ask you to find out its 2's complement, what you do? You scan the number from the right, okay, and until you find the first one. So this number is 0, it will come down as it is. This number is 0, it will come down as it is. Now this is the first one we see from the right. It also comes down, so we also have it as it is, and then we change what's after the first one. So this 0 here will become 1. This 1 will become 0, and then 1 1 1. So this way we have our 2's complement. Or example, another example, or if you have the first one, as this number 5, you scan it as well, just like we did, but obviously we have no 0, so we start straight with the 1. This one will come down, okay, and then we just basically change what's left. So we have minus 5 using the 2's complement technique. Okay, as I said to you in the exam, I will make things clear. I will tell you which method to use. I will say to you, convert this into 2's complement, 1's complement, sign magnitude, perform the addition, and so on. I will tell you which method to use. So, but you have to be very confident in working out with the methods. Now let's take a live example. I will take an example. Okay, if I say to you, let's go back to the to our original problem. If I say to you, perform the following, take one from. Oops, this should be minus. Sorry. Okay, this should be minus. Okay, perform the following. Take 1. 1 from 5. Now again, this number, which is the second number that we're taking it from, we will change it to its complement, to its 2's complement. So as we said, 1 is in binary is 1 0 0 0. Now in the 2's complement, right? Okay, I'm going to open the chat. You tell me what the 1 will be in its 2's complement. Tell me what the 1 will be in its 2's complement. Okay, thank you. Yeah, that's right. Thank you. You all know. Excellent. Right. So seems that you do understand this point. That's good. Right. So we get this number down as per our rule, and then what's left behind it, we change. So this number will be minus 1 using the 2's complement technique. See, the 2's complement technique is different from the 1's complement. The 1's complement we get 0 1 1 1. Okay, but so every method is different from the other. So again, I will tell you in the exam which method to use. Right. Okay. So let's continue. So we've got 1 0 1 0. Then we add the 1 and we do the normal the normal addition, we get 0 باليد واحد, also 0 باليد واحد, 1 plus 1 plus 1 is 1 باليد واحد, 1 plus 1 0 باليد واحد. Okay, this is also an overflow, right? See, because we've got 1 2 3 4 as in here and in here. So this is the original number, but we have an overflow as well. So we've got 5th digit. Now remember this rule: in the 2's complement, if you have an overflow, you ignore it. Okay, not like the 1's complement. See, the rules are different. The rules are different. In the 1's complement, if you have an overflow, you add it back to the result. While in the 2's complement, if you have an overflow, you just basically ignore it. Okay, so just concentrate on the actual number. So the actual number, don't forget, this is the most left hand digit or bit. So it is 0, which is positive. So we have plus 4 in decimal. So again, 5 minus 1 equals plus 4. Okay, so can you see our word is correct? See, the methods are different, but you should get the same result. The methods are different, but you should get the same result. Now let's take another example, which is the one we dealt with earlier. If we have this time again, if we have 5 in decimal minus 6 in decimal, obviously again we know the result. The result should be minus 1 in decimal. Now let's convert this number to its 2's complement. This number is 0 1 1 0, which is 6. Now if we do convert, now I'll try again. Try to convert this number to its 2's complement. See what you get. What do you get by converting number 6 to its 2's complement? Okay. Yeah, some of you are right, some of you are not quite right. Yeah. Okay. Right. Easy, guys. Some of you did get it right. As we said, we look for the first one. So this is not a 1, so we bring it down. This is a 1. Yeah, we bring it down. So whatever left after, we change it. So we get 0 and we get 1. Okay, so this number is minus 6. Sorry, I start losing my voice here. Right. Okay. So we do the addition here. Plus 0 1 0 1. Okay, we do the addition. You've got 1 1 1 1. Is that right? Okay, by adding, look, I'm adding 1 plus 0, 0 plus 1, 1 plus 0, 0 plus 1. You get 1 1 1 1. Now notice something. The most left-hand number here is 1, which means it is minus. Now it's the same idea. If you get 1 as the bits themselves, not the overflow, the bits. If you get 1 to the left-hand side, it means that this is a negative number. So you have to change it back to its original number by doing exactly the opposite operation. So again, you have to bring the first one down and then change whatever left after the one. So this number is actually 1, as you know. See, the reason we changed it back, because it is impossible to know the 2's complement by conversion. You cannot just convert this 2's complement to a decimal. It will not work. So you always have to get the pure binary, the original binary, in order to convert it back to the decimal. So we do this. But again, remember that you began with 1 here. So this one has to, you began with 1, which means a minus. This minus has to be brought down here. So you have minus 1 in decimal. See, again, this is the same result we get. So hopefully this shows that our work is correct. Okay. So this is the end of today's lecture. I hope you find it quite useful. If you do, I'm going to open I'm going to open a chance for you just for 10 minutes to ask questions. If you've got, right, guys, I'm a bit worried now that I asked you a couple of questions at the beginning of the lecture, and you seem to be a bit reluctant, and this is a bit worrying. So I want you to make sure that you study, always. After every lecture, you've got a week to revise what we had and to study further as well. So you've got some work to do this week. Make sure that you understand what's binary, what's a decimal, what's a hexadecimal, an octal system, and you've got to know exactly how to do the conversion between them. And also we added to this lecture today the operations, so you've got to know how to do the normal binary operations. We had the addition, the subtraction, the multiplication, and we also did we dealt with the negative numbers. الأعداد سالبة. Okay, so this is today's lecture. I'll open the way for you to, the chance for you to ask questions, and then if you still have problems or questions, you can always email me. So we'll have the first question from Munira. Okay, Munira, speak.
Yeah, hi, Doctor. I would like to ask you about the minus. How I can differentiate between if it's this one, it's mean minus or zero. You will never give us the numbers in...
Munira, can you hear me? Now your voice got cut off a little bit. Can you repeat your question, please?
Yeah, do you hear me, Doctor?
Yeah, speak.
Yeah, I would like to ask you about how we know the differentiation between this one if... Doctor, do you hear me?
Well, speak again slowly. I'm having difficulty in connection. What is the difference between?
Yeah, Doctor,
go on,
do you hear me? Okay. How I know the difference? If this one it's mean zero, it's mean minus or just once. I understand the rules for each one, but I don't know the minus in the number. You give me a number in binary and you tell me minus number. How I will differentiate?
Yeah, I think so.
Is it my question or not?
السؤال كان كيف نفرق بين انه هل هذا رقم سالب ولا هو رقم اصلي؟ يعني مثلا على سبيل المثال لو اخذنا هذا الرقم 1 1 1 1 الباينري العادي هذا يساوي لي اللي هو هذا طبعا باينري يساوي لي بالحوالي العادية يساوي لي 15 بالديسيمال. Okay, 1111. Now also it could mean that this number if it was in complement, it could, or sign magnitude, it could mean that it's equal to minus 7. I think this was your question, okay, if I'm not mistaken. Now in the exam, again, I did say at the beginning of the lecture, I will make it clear. I will make it clear that, I want you to deal with a normal binary, or I'm telling you that we have a sign magnitude, or we have a ones complement, or we have a twos complement. If I say to you we have complements, or we have a sign magnitude, you will know that this number is a minus. So you'll think, okay, then if this is a minus, what is this number? This number is 7, so you have minus 7. But if I do not say anything, which means you've got to deal with this number as a normal binary, which will mean 15. I hope this this was your question and I answered it. Any more questions? Any more questions, guys? Any more questions? Okay, no question. Can you all hear me? Have you lost connection? Can you all hear me? You can, yeah, so you're still with me. Okay, so no more question. Okay, that's impressive. So I hope you do understand the lecture. Now again, if you have a problem or if you do not understand anything, or if you didn't understand anything, please email me. Hopefully next week, what I will try to do, I'll probably set an exercise for you. I'll do a collection of questions. I will do some questions for you, practicing questions so you can practice yourselves. But I do want you to revise the lecture I put the slides on the internet, but again, especially this lecture's slides, I didn't find them very, I found them very confusing. So you could, you do go to the internet and stuff. Right? Okay, we've got a question here from Amjad. Right, speak. هاي
اتوقع ان احنا مو مضافين عندك في البلاك بورد.
انتم مو مضافين عندي؟
ايه في البلاك بورد، احنا بس في الميتنج، بس في البلاك بورد في الماده الاصليه انه حتى المحتوى مو موجود عندنا.
لما هو احنا يعني الكوميونيكيشن كان في البلاك بورد. Okay, so you have no problem. We are dealing in Blackboard, okay? And if I have any assignment for you, I will send you announcements. So you should be fine.
لا حتى العروض ما تطلع عندنا.
لا المفروض تطلع عن I added it to the content collection. يعني العروض.
إيه عشان كذا أنا أقول لك إحنا مو مضافين.
مو مضافين والله دقيقة إذا مش مضافين يعني if you're not added to my session, you've got to now. Okay, I'll show you how to get the slides. Right, follow me on my desktop again. No, okay. There's a problem, I think here. Can you see my desktop?
إيه نقدر.
Right, guys. Right. I'm gonna have a vote here. Can you see the session on the internet, the Blackboard? Can you see it on my desktop? Yeah, you can. Okay, so I'm still working then. Okay, cool. Right. So right. Let's take you here now to get the slides. Now, then you tell me if you don't have this. You go. Obviously, you get this page. Obviously from here you can go to the recordings from the tools and the Blackboard, but also from the content collection, which is the one here. You go to your subject, and then I've put them here. You get the slides. Can you see the slides? You click on the slides, and you have them all here. You can just click on them and download. Did you see what I did now? Did you see that? Did you see that? You didn't see that. Okay, right, you didn't see that. Now hang on, let me try again. Stop sharing. Let me start sharing. Okay, let's go to the internet. Now, okay, let's go. Okay, can you guys see the organization content slide? Can you see that? Yeah, you can. Okay, right. You can. Excellent. Right. So again, now look at the left-hand side. Look at the mouse in the left-hand side. What you do, you go to content collection. You've got the control panel. Then you got the content collection. You go to your subject, which is here. Now you go to slides. Okay, and you will have the slides that I put up. You will have them here. You can just download them. Did you see that? Did you see that? Did you see that, guys? Yeah? You saw it? Okay. Now this is the way to download the slides. Now if you have a problem in doing so, you probably got to contact the actual, the Blackboard support team, or if you still have a problem, then we can sort something out. Now, did I have a question? No. Someone asked a question. Okay, does anyone have a question? Yeah, Mona? Oops. Yeah, speak. Mona?
عفوا أستاذ، بس اللي طلعت لنا ما يطلع لنا احنا في البلاك بورد.
Okay. Now, I will do my best to get this sorted. Right, what I'll do. Okay, what I'll do, I'll put them on my Dropbox. Okay, if you do have a problem in early next week, I'll try to contact the the IT support center myself. If you do get the problem early next week, email me, and what I'll do, I'll put the slides on my Dropbox, and I will give you the link. So if a few of you can email me, I'll give you the link for the slides. Then you can guys share between you. You can share the slides between you. But also I can put them on my Dropbox, and you can download them from my Dropbox. Okay. That's if this problem continues for Sunday or Monday. Okay, so let me know by Monday if you still have the problem of not seeing the slides. Right? Any more questions? No more questions? Okay. Now, so we'll pack it up then, guys. This is today's lecture. I really encourage you to revise what we did and stuff. Right. So, and I'll see you inshallah next week. And if you do have questions, always email me, and expect the reply in 3 days, 2 or 3 days, because obviously I do get like hundreds of emails, about 100 and 150 emails a day. So I have quite a lot of emails. So, when you email me, just wait 2 or 3 days for the answer to come. So, okay, fi aman Allah, and I'll see you next week.